Hello, I'm Brian Young, and today we're going to be doing Module 00105, Introduction to Construction Drawings. Let's get started. When you're working in a craft to build a building, you're working with a lot of different crafts alongside you. Carpenters, plumbers, electricians, roofers, masons, sometimes iron workers, sometimes sheet metal workers, HVAC, and you all have to have a common goal. You have to know exactly what the finished product is going to look like, how it's going to function, how all of the components are going to come together. And that's what construction drawings are all about. You'll hear them called blueprints, you'll hear them called prints, but basically, an architect and engineers get together. They talk with the customer and see what it is that the customer needs, and they try to fulfill that need. They try to design a building that is structurally sound, but also aesthetically pleasing. Uh, let's say a guy sells hot dogs and he uh, makes it rich, he's very successful. So he wants his buildings to look like hot dogs in buns. So he goes to an architect and he talks to them, tells them what he wants. He wants his buildings to look like a hot dog in a bun, and they'll design it and they'll work with engineers to make sure that it's structurally sound and that it's aesthetically pleasing and everything fits inside. If it's a restaurant, there are tables for people to sit at. When they get finished, they'll show the drawings or a computer rendering of the building to the owner, and if it's what he wants, then they'll start construction. But all of the trades working together have to have that common goal. They have to know exactly what it is that they're working toward. That's what these construction drawings are all about. Successful completion of this module will prepare you to describe components and features used in construction drawings and identify how the drawings are different. So, summarize the purpose of 6 basic construction drawing components, list and explain the significance of various drawing elements such as lines of construction, symbols, and grid lines, explain how dimensions relate to various drawing scales, and demonstrate how to use an engineer's and architect's scale. Identify the 6 types of construction drawings. There are performance tasks that you'll do. You'll use a set of drawings to locate specific things on the drawings. So the overview says various types of construction drawings are used to represent actual components of a building project. The drawings provide specific information about the location of the parts of a structure, the type of materials to be used, and the correct layout of the building. Knowing the purpose of the different types of drawings and interpreting the drawings correctly are important skills for anyone who works in the construction trade. This module introduces common types of construction drawings, their basic components, standard drawing elements, and measurement tools that are typically used when working with construction drawings. 1.0.0 construction drawings and their components. It just goes on to reiterate the tasks that you'll do. Construction drawings are architectural or working drawings used to represent a structural system. These were referred to traditionally as blueprints because years ago the process of reproducing these drawings resulted in white lines on a blue background. They were kind of purple, but they were called blueprints. You could make one drawing or a couple of drawings using graphite pencils, and then using a special process, you would transfer that design onto sheets of paper that were coated with a chemical. Anywhere the graphite lines were, the paper would not turn purple. So you'd end up with white lines on a purple background. Now today they're done on computers with computer-aided drafting. You can't fit all of the information on the blueprints. So there's also a specifications that comes with it. Sometimes specifications can be just notes on a blueprint. Sometimes they're as big as a dictionary. They're huge, 600 pages of specifications, depending on the size of the job and what specifications are called out. For instance, that hot dog vendor might use a specific brand. He might use all KitchenAid, cooking equipment, refrigeration equipment, what have you. They'll say that specifically that every one of his stores he wants to use the same equipment so they can buy spare parts and be able to service any of the stores. So they'll put that in the specifications, exactly what goes into the store. Specifications are precise written presentations of the details of a plan, often abbreviated as specs. It says before the 1950s, construction drawings were all drawn by hand. This was a long and tedious process. If there was a mistake on the drawings had to be redone from scratch. But by the 1980s, everything was done with computer-assisted drafting. Ultimately, CAD has the following advantages over hand-drawn construction drawings. They're automated. Computer performs calculations quickly and easily. Changes can be made easily. Common used symbols can be retrieved without difficulty. And CAD can produce three-dimensional modeling of the structure. Nowadays, they're using something called building information modeling. Traditionally, building information modeling was a system of paper-based documents and construction drawings designed to monitor and track specific information about the building. So they would document the building as it was being constructed, and they would put all of those into a document. Now they have drones, they have X-ray equipment, they have a lot of information that they can put into this building information module or modeling. And they give all of that to the owner so that he's got it for reference for later on if he needs it. Regardless of how the drawings are created, there's almost always changes that occur during design and construction phases. This means that the drawings need to be updated to reflect those changes. So you have drawing revisions. On your blueprints, you will have the latest revision number and the date that the revision was made. Sometimes the person who made the revision, they'll put their initials next to it. But you need to make sure that you're always using the most current set of blueprints because things change, sometimes weekly, sometimes daily. It's rare that you draw the drawings and they stay stagnant the entire job. Someone will think of something a month down the road and they'll say, oh, you know what? We need to put in an outlet here for a hot plate so that when we're serving out in the dining room, we can prepare things or keep things warm while we're serving the customers. All right, well, let's do that. That's a revision. Let's draw it in. Let's give it its own circuit number and bring it back to the panel. How do I say this? If you're on a job and you're working as a tradesman, I'm going to say electrician because that's what I am, and somebody comes in with a hard hat and tie and long sleeve shirt and they say, hey, we've changed our minds. Those lights aren't going to go there. You need to put those lights 18 inches away from the wall instead of 3 feet away from the wall. You do not have the authority to change what is on the blueprint. You have to do what's on the blueprint. You tell them respectfully, you need to talk to my foreman or the general foreman or go speak with the architect. And that's it. Don't say any more to them. Don't be disrespectful. If you have to walk away, because you don't want to get into an argument with them. You'll lose your job. But you take it upon yourself to move the location of those lights. Now there's been a revision that the customer didn't have to pay for. Any change to a building, especially after work has started, is a change order, and the contractors make money off of that. So don't fall into that trap of trying to be a nice guy and just do someone a solid. Yeah, I can move them. That's 18 inches. I can just move them over. No, it has to come down the chain of command from the architect to the general foreman to your foreman to you, and then you can move. So most construction drawings are laid out in a fairly standardized format. Sorry, this is 1.1.0 basic components of construction drawings. The title block, it's part of the drawing that includes some general information about the project. The architect's name, the name of the building, the address of the job, revision block, these things will be in the title block. Border, the drawing area, the revision block, the legend, and a north arrow. The first thing to look at on any drawing is the title block. The title block is normally in the lower right-hand corner of the drawing or across the right edge of the paper. It serves two primary purposes. First, it provides information about the structure or assembly, and it's also numbered so the print can be filed easily. So here's the title block on this sheet, and you can see this is sheet A-110. All of the A's are architectural, M's are mechanical, E is electrical, P is plumbing, different things like that. So you're going to look for those numbers. Different companies put different information in the title block. Generally, it contains the following: the company logo, the sheet title that identifies the project that's highlighted, the date the drawing was checked and readied for seal, the drawn by, the initials of the person who drafted the drawing, the drawing number, the scale, that's the ratio of the size of the object as drawn to the object's actual size. It might be 1/4 inch equals 1 foot, or if it's a civil plan, it could be 1 inch equals 50 feet. It could be a huge ratio. And the revision block, the information on revisions, including at a minimum the date and the initials of the person making the revision. 1.1.2, the border. The border is a clear area of approximately 1/2 inch around the edge of the drawing. It's there so everything on the drawing can be printed or reproduced without losing any of the information. The drawing area represents the information constructing the project, such as the floor plan, elevations, and building section details. 1.1.4, the revision block. The revision block is located in the drawing area, usually in the lower right-hand corner of the title block or near it. Different companies put the revision block in different places. This block is used to record any changes to the drawings. It typically contains the revision number, a brief description, the date, and the initials of the person who made the revision. So you can't put a lot of information in this one line, but they'll put a note number, this triangle, or they'll put some way of finding it on the blueprint. And a lot of times what they do on the blueprint is they'll put a cloud around the change. They literally will draw a cloud shape around that change, and they'll show what's new. Or if it's something being demoed, they'll draw a cloud around it and then draw everything in dotted lines saying, this is going to be removed, this is coming out. Caution, it's essential to note the revision designation on a construction drawing and to use only the latest version, otherwise costly mistakes may result. The legend, 1.1.5. Each line on a construction drawing has a specific design and thickness that identifies it. Note that some of the lines may be used to identify off-site utilities. This is highlighted. It says the identification of these lines and other symbols is called a legend. So here's a sample legend of HVAC. These are ducts. So they have a ceiling diffuser, the return air grill, the supply duct up and the supply duct down, return ducts. So this is what they'll look like on the drawings. They put that in this legend so that when you're looking at the drawing, if there's something you don't recognize, you can look at the legend and find out what it is. A north arrow. Most construction drawings have an arrow indicating north. It may be located near the title block or in some other conspicuous place. Sometimes people don't put their buildings straight on a lot. Sometimes, let me see if I can do this here. Let me see here. Where's my, there. Sometimes this is the building and it looks like it's square with the roads or what have you, but they might say this is north, meaning that this corner is facing north and this corner is facing south. They might call this the north face and the east face and the south face, but this is true north. They don't always put that on drawings. If that's not on the drawing, then the top of the print is north and the bottom of the print is south. The right is the east and the left is the west. But you can see they don't have to position their buildings true north. They can put it catty corner on the lot. Let's say that this is a road over here, and maybe it has a little turnoff that comes into a parking lot. So here's your parking lot, something like that. Yeah, it's not a great drawing, but you get the idea. They don't have to position this building true north. You're allowed to put it however you want it. So look for that north there. The north arrow is a reference point that helps verify the location of the objects, walls, building parts shown on the construction drawing. The legality of construction drawings. Well, this just says that the construction drawings are a legal document. They're incorporated into the building's contract by reference, making them part of the legal documents associated with the project. When the drawings have been examined and approved, it has an architect's seal and an engineer's seal, and the owner has looked at them and said, yeah, this is the building I want. You spend 6 months building that building and the owner says, no, that's nothing like what I wanted. Well, they're still going to have to pay because they agreed to it. And all of that is part of the documentation. So those blueprints are a legal document. Oh, here it is, Plan North. It says, when true north is not noted on a drawing, it cannot be verified. Plan North is used to describe direction on the drawing. This helps communicate the location of features on a drawing. So Plan North is toward the top of the page, east is to the right, south is to the bottom, and west is to the left. Drawing elements 1.2.0. Various drawing elements make it easier and quicker for people to read and understand construction drawings. This section covers several of the most common drawing elements. 1.2.1, the lines of construction. It's something called the alphabet of lines. The lines commonly used on a drawing are sometimes called the alphabet of lines. So even the thickness of a line will tell a story. If it's a solid line, it's object lines. That'll be like walls or windows or doors. A dimension line ends in arrows or these nodes, these dots, and it'll say it's 6 feet 6 inches from this point to this point. So it'll give you a dimension. These are leaders. It's pointing to a specific point of interest on the blueprints. Sometimes it's the center of a column. It might have this saying the center of this column is located exactly 3 feet 6 inches off of the west wall and 3 feet 6 inches off of the north wall. So it pinpoints the center of that column. Sometimes there may be an opening. There might be a circular opening, and it might say the diameter of that opening is 3 inches. And maybe on the drawing, it's too small to put any information inside that small little circle. So over here, it says 3-inch diameter, DIA, period. And it says that the opening, this hole, is 3 inches in diameter. Property line. Here's a section cut line. We'll talk about those more later. But basically, you can cut the side of a wall and look inside that wall and see how it's constructed. Um, these are break lines. So one page well, they have break lines and they have match lines. These to me look closer to match lines where there will be a drawing, let's say A1, and then there's more of the building above this drawing that they weren't able to fit on the page. So they'll say that this is a match line with A2. And you go to A2, and this match line will be at the bottom of the page, and it'll say A1, A2, saying that's the same point on these two sheets. They match up. That's a match line. Break lines are if you're drawing a wall and the wall is 50 feet long and it's identical. You don't have to draw a 50-foot wall. You can draw 5 feet on one side and 5 feet on the other and put this break line in the middle saying there's a lot more that we're not showing you, but it's all typical. It's just a continuation of this seawall or parapet wall or whatever it is. They can just shorten it and say, yeah, there's more. This goes on for 50 feet. Hidden lines might show an object that you can't see. It's behind something else. Center line, and we said the object line. So dimension lines establish the dimensions of a part of a structure. These lines end with arrows, dots, slashes, or dashes at a termination line drawn perpendicular to the dimension line. A leader identifies location of a specific part of a drawing. Property line indicates land boundaries. A cut line, lines around a part of a drawing that is to be shown in a separate cross-sectional view, usually zoomed in, so you get a detailed drawing where the wall is an eighth of an inch on the drawing, and then you look at the detailed drawing, and they might draw it 2 inches wide so you can see the structure of that wall. Break line shows where an object has been broken off to leave space or save space on the drawing. Hidden lines identify part of a structure that's not visible on the drawing. The center line shows the measured center of an object. So if you have like a round column, they might put a center line. They might put one vertically and one horizontally to show you the exact center of that column. And an object line identifies objects. So these are dimension lines. The dimension is usually written as a number in the center of that dimension line. So here's 6 feet 6, and here's another 6 feet 6, and here's 4 feet 2 inches. And if we're lucky, this is 17, what is this? 17 feet 2 inches. If we add these three numbers up, they should equal this 17 feet 2 inches. If you did the math or you used a calculator and these three added up to 17 feet 2 inches, and they had written 17 feet 6 inches, well, now you need a request for information. You need to ask the architect, hey, what did you mean here? Is this supposed to be 17 feet 2? Is this a typo, typographical error? Or is there something in here that I'm not seeing? Because when you add these three up, it makes 17 feet 2 inches. And if they wrote 17 feet 6 inches, we need clarification. If there's a discrepancy between the blueprints and the specifications, if the blueprints show you have 12 spare 4-inch PVC conduits coming out of the electrical room, capped off and not used, and then on the specifications they say 12 3-inch PVC spares, we need clarification. There's a discrepancy between the blueprints and the specifications. So you'd give them an RFI, request for information. It's a legal document. You'd fill it out saying exactly what it is that you need to know, and you would send that to the architect or the engineer and ask them to clarify which is the right information. Abbreviations, symbols, and keynotes just save space on a drawing. We don't have a lot of room, so they'll abbreviate things. They'll use symbols. We don't draw. Oops, I have to cock my head here. I can't see the edge of my. We don't draw a receptacle. We don't we don't draw a receptacle in the wall. It would be too big. If there's a room and there are receptacles around that wall, we use a circle with two lines, and that's a duplex receptacle. The regular kind of duplex receptacle that you're used to seeing, that's the symbol we use. And if there's a switch, it's S. If it's a three-way switch, we put S3. If it's a four-way switch, we put S4. So there are different symbols that we use on the drawing that are faster and easier to draw than an actual representation of the object itself, and it also saves space. We don't want to have to write out the word receptacle on the drawing. If it's a GFCI receptacle, well, then we'll put GFCI there. And sometimes it's a specialty receptacle. It might be 240 volt instead of 120 volt. So they'll have three lines. So there are all these different symbols that we have on the drawing. And it saves space. Architects and engineers use systems of abbreviations, symbols, drawings that represent a material or component on a plan, and keynotes to keep plans uncluttered, making them easier to read and understand. Examples of some of these items appear throughout this module. Following is additional information on these items and some variants that are commonly used. Sometimes they have a door schedule that tells you all the doors on the job. And inside the doorway, they'll put a hexagon with a number in it. 1, 2, 3, 4, 5. So this is a number 1 door. It's 3 feet 6 inches wide and 6 feet 6 inches tall. It's 1.5 inches thick wood with no window. And if it's a number 2 door, or they might use letters A, B, C. If it's a B, maybe it does have a window. And if it's a C, maybe it's not 3 feet 6. Maybe it's 3 feet even. Maybe some of them are wider for handicapped, so they're 4 feet wide. They'll be in a door schedule, and they'll use those hexagons in the doorway on the drawing because they can't put all of that information on the drawing. They'll put it in the door schedule. Abbreviations used in construction drawings are short forms of common construction terms. For example, the term on center is abbreviated OC or AFF, above finished floor. So here are some common abbreviations. A lot of times they use a standardized set of abbreviations and symbols. Some companies will use alternate symbols. They'll put it in the legend. They'll tell you what symbol they're using. Here's a center line. Here's the diameter. Here's elevation. Here's and, of course, and width. And there's a plate, by, number, at, square, angle. These are all different symbols that they'll use on the job. Electrical, elevation, equal, end wall bars. So all of these, if you see an abbreviation on a blueprint, you don't know what it means, just look up the abbreviations legend and it'll tell you. You can check it out. So here's a highlight. It says, the symbols used for each set of plans should be indicated on the title sheet or other introductory drawing. So they'll tell you if they're using a standard set of abbreviations and symbols, they'll put that, this is the American standard symbols and abbreviations. They'll put on there what they're using. Architectural symbols, this is the type of material. Here's block, here's concrete or cement, structural clay tile, general brick or similar. Here's bat or blanket insulation. Here's masonry. You can see that they try to make the symbol look like the thing that it represents. This is the finished lumber, and this is masonry, and this is sheet metal. So you can kind of see how those look like wood, masonry blocks, and sheet metal. Civil and structural engineering symbols. This cross hatching is the earth. This is like the dirt. So this is, a cement and concrete. This one has rocks in it, so it's concrete. This one doesn't, so it's cement. This is a footer. Here's an expansion joint, okay? Contraction joint. They'll show you. And then this cross-hatching, like I say, is the earth. Here's an I-beam, an angle iron, all of these different symbols. Here are some mechanical symbols, pressure gauge. Anytime you see this bow tie, that's a kind of a valve. Like here's a gate valve or a globe valve or a check valve. So they have a valve with a pressure indicator on top of it, a pressure gauge. And here's some plumbing symbols, a lavatory. This is the sink, the toilet. They're calling it a water closet, double sink, hot water heater. There's the water main. Here's a bathtub. Some plans use keynotes instead of symbols. A keynote is a number or a letter, usually in a square or circle, with a leader and an arrowhead that's used to identify a specific object. Part of the drawing sheet, usually on the right-hand side, lists the keynotes with their numbers or letters. The keynote descriptions normally use abbreviations. So here are keynotes. There would be a list of notes somewhere on this print, and they'd say, 1, this is corrugated steel, or this is whatever it is. Here's 2, this might be a 1/4 inch thick plate that's bolted every 2 inches. This might be a column. How big is the column? What is it made out of? All of that will be contained in the note. And then here's a footer, a base plate, the bolts that hold it down, how long are they, and are they installed in the footer, the concrete. This is a steel that ties all of the concrete together and grounds the building. So all of those are notes. Those are keynotes. RFI, request for information. This is what we were talking about before. A request for information is used to clarify any discrepancies in the plans. If there's a discrepancy, notify the foreman. The foreman will write up an RFI explaining the problem as specifically as possible and putting the date and time on it. The request for information is submitted to the superintendent, who passes it to the general contractor, who passes it to the architect or engineer, who then resolves the discrepancy. They try to get these back within 48 hours. Sometimes it's difficult to do that, but they don't want to hold up the job with an information problem. So they want to try to resolve it and get back to you. And they'll get back to the superintendent in writing. Everything's done in writing because it's legal. Care of construction drawings. This construction drawings and mobile devices used to store drawings and other supplemental documents are a valuable record and should be protected. Follow these rules when handling construction drawings and mobile devices. Never write on a construction drawing without authorization. Keep the drawings clean. Dirty drawings are hard to read and can cause errors. Fold the drawings so that the title block is visible. Fold and unfold the drawings carefully to avoid tearing them. Do not lay sharp tools or pointed objects on construction drawings. Keep drawings away from moisture. Don't set your coffee cup on the drawings. Keep drawings away from moisture. Make copies for field use. Don't use originals. Use a case when transporting or storing a mobile device. Keep the mobile device charged and make sure that all the data is backed up. Protect the mobile device display with a screen cover. Avoid prolonged exposure of the mobile device to direct sunlight. And keep the mobile device away from water, food, and drink. 1.2.3, using grid lines to identify plan locations. Think of using a road map to find a particular sheet. The map may use a grid to make locating the detailed area easier. For example, the index might indicate that the street is in the section B3, referring to B along the side of the map and 3 along the top. So they do the same thing on these drawings. They have numbers on the top and letters down the side. Usually these are support columns, And each one of these support columns will delineate a bay. Each one of these squares is a bay. So B3, it'll tell you from B2 to B3, or B2 to C2, C2, B3 to C3. They'll tell you where it is on the drawing. Okay, 18 feet. So every 18 feet they have one of these columns, and they're 12 feet this way. Each one of these is a bay. The numbering and lettering system begins in the upper left-hand corner of the plan. The numbers are normally across the top, and the letters are along the side. And to avoid confusion, certain letters and symbols for 0 are not used. They omit from the grid lines the letters I, O, and Q, and the numbers 1 and 0. That way, like I say, it just tries to mitigate any confusion that would come from a Q looking like a 0, or a O looking like a 0, or an I looking like a 1. Dimensions and drawing scales. Dimensions and their associated drawing scales provide information that's essential for correctly translating construction drawings into actual buildings. So they're going to tell you a 1/4 inch equals a foot, or a 1/2 inch equals a foot. I've seen very detailed drawings of cabinetry that said 1 inch equals a foot. So the cabinets were, nearly 4 inches tall. So it was a very close drawing of those cabinets. Dimensions. The dimension is a measurement written as a number, and it may be written in inches with fractions, in feet with inches, or in inches with decimals. A lot of times they'll put a dash between the feet and the inches. 1 foot dash 2 inches. So here's exterior and interior dimensions. A is an external, they might call it OD, outside diameter, and B is an ID, inside diameter. We electricians always size our pipe according to the ID, the inside diameter of that pipe. Going green. All right, I'll let you read that on your own. Caution, when a plan's marked not to scale, NTS, workers cannot measure dimensions on the drawing and use those measurements to build a project. Not to scale drawings give relative positions and sizes. The sizes are approximate and are not accurate enough for construction. A lot of times on the drawing they'll put NTS and field verify. So they're saying there's a beam and we want to put a light exactly 12 inches to center off of the edge of that beam. And then they say field verify. Verify where that beam is, verify where that fixture is going to go. And if they drew it, they didn't draw it that accurately, they just say not to scale. Drawing scale. On a site plan, scale may read 1 inch equals 20 feet. This means that every inch on the drawing represents 20 feet in the real world. The scale used to develop the site plans is an engineer's scale. Usually on an architect's scale, it's inside the building, it's much smaller, like a 1/4 inch equals a foot. So each inch represents 4 feet, whereas up here, each inch represented 20 feet. I've seen these civil plans where they show almost a whole city block, and they might say 1 inch equals 50 feet. And they'll show you the street and the street light and the utility and sewer and gas lines underneath the ground, and they'll show the topography of the land, and then they'll position the building where it's going to go on that piece of property. Not to scale. NTS, not to scale. Checking scales on drawings. Normally the scale of a drawing is marked directly on the drawing itself. If it's not, however, do not guess what the scale is. Rather, compare different scales by identifying a given length on the drawing, and then find the scale that measures the pipe at 8 feet 6 inches. Check at least 2 items on the drawing. this way before proceeding. It's difficult. Sometimes when they make a copy or they print out on a dot matrix printer, they have a large printer that will print 18-inch by 24-inch. It can do drawing sizes or blueprint sizes. I've seen it where the computer put a margin around the drawing. So they had the drawing scaled exactly in the computer, and when it printed on the printer, it was a half an inch narrower, the entire drawing. So nothing scaled exactly right. Everything was just a little bit off because they decreased the dimensions of that drawing in the real world and printed it out and sent it out to the job. And everybody was having quite a time with it. They had to call the company and tell them what was going on, and they figured out what the problem was, and they were able to take that border out of the program so that it wasn't putting in a white border around the drawing. They took that out so that when it reprinted, it printed the full size. And now, if it said a quarter inch equals a foot and something measured 20 feet, you could measure it and see, yes, this is right. This is right. This is 5 inches times 4 feet per inch. So this is 20 feet. It was scalable. The other was not scalable. You'd have to use a multiplier like 0.936 or something. You can figure it out, but it's a heck of a deal to have to go through. Here's a schematic drawing. This is showing a start-stop station. It's showing the terminations of these wires, where they would land in the real world. Actually, it's not the real world. They're showing the electrical flow of this drawing. So it says, in a single line or schematic electrical drawing, the line represents electrical wiring routing through a conduit. So these are electrical wires, but these two items may not be right next to each other. This could be 100 feet away. This could be up in a control room, and these wires will go up to that control room so that they have the start-stop up there where they need it. They might even put 2 start-stops, one up in the control room and one out in the field where the maintenance guy can stop it, lock it out, and then he can work on that motor, and then he can test it when he gets done by starting it and stopping it. An orthographic drawing goes back at 30 degrees, and it's a more three-dimensional representation of the thing. Sometimes they'll do that as a sales tool. When they draw the building, they'll draw it in orthographic because that's closer to what people actually see. And it's hard for people to look at these drawings and imagine what it is that's being represented. But when you see it orthographically, you understand right away. Oh, okay, so here's the front, and here's the right side, and this dotted line represents the bottom of this channel that's cut away. And then here's with the top view, you see the sides and you see the channel here. But orthographically, it's a lot easier to see, like this one. 1.4.0, measuring scale. Standard and metric rulers and measuring tapes are usually used in a shop or in the field for a variety of measuring tasks. However, there are other types of rulers called scales used by draftspersons to produce drawings. They're also used by many workers to take scale measurements of drawings. These include the architect's scale, the metric scale, and the engineer's scale. And the metric scale is a straight edge measuring device divided into centimeters, with each centimeter divided into 10 millimeters, usually used for architectural drawings, sometimes referred to as a metric architect's scale. So the architect's scale here, I've got a highlight. It says the triangular architect's scale is most commonly used because it can combine up to 12 different scales on one tool. So this is what it looks like. If they showed it from the end, you'd see it looks like a triangle. There are 3 sides to it. Each one of those blades coming off has 2 sides to it. So that gives you 6 sides, but each side has 2 scales. You see, here's 1/8 inch scale. If you start from the left and go to the right, we're talking about 1/8 of an inch. So there's 0. There's 1, 2, 3, 4. There's 4/8, 5, 6, 7. There's 8/8, 12, 16, 20, 24, 28. That's measuring from the left going to the right. The 1/4 inch scale starts on the right and goes to the left. So there's 1, 2, 3, 4, 5, 6, 8, 10, 12, 14, 16, 18, 20. So you have 2 scales on one blade of this architect scale, the triangular scale. They're saying they can fit up to 12 scales on this one tool, so it's very convenient. And after the 0, they have these smaller demarcations, which are inches. So here's feet, 1, 2, 3, 4, 5, 6, 7. This is 7 feet, and it's longer than 7 feet, so you hold the end of the thing on the blueprint you're measuring. You hold it on the 7, or yeah, this is 7, this is 8. And then you measure back past the 0. There's 3 inches. Well, let me see here. 1, 2, 3, 4, 5, 6. Yeah, 7, 8, 9, 10, 11, 12. Yeah, their scale's a little bit off. I think that's 3 inches. I think that's 6 inches. I would call this 7 feet, 6 inches is what I would call this. They're showing, they're showing a blow up here where it's actually 5 inches, 7 feet, 5 inches. So they're saying it's not touching this line, it's touching the one behind it. I don't agree with them, but we'll just go with it. 7 foot, 5 inches. 1.4.2, the metric scale. Similar to the architect scale is the metric scale, sometimes referred to as the metric architect scale. They divide this into centimeters, and they divide each centimeter into millimeters. So this says 1 millimeter equals 200 millimeters. The 50 millimeter scale measurement equals 10 meters. So each one of these is a millimeter, and each one of them represents 200 millimeters. So 200, 400, 600, 800. Now I'm wrong, because this is supposed to be 5 meters. So each one of these is a meter. 1, 2, 3, 4, 5. Yeah, I'm sorry. This first divot is 200 millimeters, 400 millimeters, 600 millimeters, 800 millimeters, and a meter, 1,000 millimeters. So each millimeter represents 200 millimeters. So there's 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. Here's 10 meters. That's how you use it. I'm still not used to the metric system. 2 common length measurements used with metric scale on an architect drawing are the meter and the millimeter. All right. There, that's a highlight. The meter and the millimeter. On drawings drawn to scale between 1 equals 1 and 1 equals 100, the millimeter is typically used. The millimeter symbol, mm, will not be shown, but there should be a note on the drawing indicating that all dimensions are given in millimeters unless otherwise noted. Okay. Engineer's scale. So these are much larger, and they're done in tenths instead of sixteenths. The engineer's scale is used mainly for land measurements on site plans, which means the scale must accommodate very large measurements. Each engineer's scale is set up as multiples of 10, and the measurements are taken in decibels. This is different from the architect's scale in that the units represented by a portion of an inch. The most common engineer's scales are 10, 20, 30, 40, 50, and 60, which can be combined with the triangular engineer's scale. So this says each inch represents 10 feet. This one, each inch represents 50 feet. Okay. For each scale, the measurement can represent various units derived from that scale number and a multiple of 10. For example, on a 10 scale, 1 inch can represent 1 foot, 10 feet, 100 feet, and so on. On a 50 scale, an inch can represent 5 feet, 50 feet, or 500 feet, and so on. One point 5.0, 6 types of construction drawings. We have civil, architectural, structural, mechanical, plumbing, and electrical types of construction drawings. So, as mentioned previously, other types of drawings and documents may be included to supplement a set of construction drawings depending on the type and use of the building. These could include fire protection, shop drawings, as-builts, or change orders. Did you know energy efficient design? It says simulation tools with BIM software allowed architects and designers to look at different building designs and test how energy efficient a building will be long before ground is even broken on a project. These tools allow the user to simulate sunlight and shading throughout different seasons based on the exact location of the project, along with existing surrounding landscape features, buildings, and structures. 1.5.1, Civil Plans. Civil means the earth, so civil plans, drawings that show the location of the building on the site from an aerial view, including contours, trees, construction features, and dimensions. Also called site plans, survey plans, or plot plans. That should be a highlight. Also called site plans, survey plans, or plot plans. They show the location of the building on the site from an aerial view. A civil plan also shows the natural contours of the earth represented on the plan by contour lines or topographical lines, solid or dashed lines showing the elevation of the earth on a civil drawing. All right, let me see if I can represent that for you. I don't know if this is gonna be quick, but and I'm not gonna change the thickness of my line. So here's my lot, and let's say I've got these topographical lines on this, and they're showing that the elevation of the earth moves around, and maybe they like this mound for some reason and they don't want to get rid of it, and they'll tell you how many feet either above a benchmark or how many feet above sea level. If they're close to the ocean, they'll give you these, and they'll say, okay, this is sloping downhill, it's sloping toward this corner. There you go. And maybe they want to put a sign up here, so they want to keep this, they don't want to get rid of it. And later on, they might bring a bulldozer in here and they might change the elevation of this land to suit them. Like maybe it's too hilly and they're going to take most of the hills out in order to put their parking lot. You don't want a parking lot that has a lot of hills, you want it to be pretty flat. So they'll come in here and they'll take a grader and they'll scrape all this down to a certain depth, a certain elevation, and put the parking lot in there. They'll probably do the same thing underneath the building. In fact, they might have a basement. Up north, a lot of times they'll do that. They'll dig down into the earth and they'll make the first floor. Maybe it's a parking garage, who knows? Maybe it's a mechanical room, an electrical room, all of the HVAC equipment, or a boiler for water, hot water. They'll put all of that underground, and then they'll put the building at ground level so you can walk in from the parking lot or the street or what have you. But these are those lines that they were referring to, the contour lines. The vertical data for these contour lines are obtained by a survey. Before a topographical survey can take place, a benchmark must be established. A benchmark is a fixed point with a known elevation that's used as the base point for measuring all elevation values. Surveyors also use a special coordinate system for identifying location, direction, and distance by utilizing lines of latitude and longitude. So they nowadays they'll probably use global positioning, GPS. Um, they can get very accurate with that. Um, but yeah, they'll have a benchmark. That benchmark again might be sea level, or there might be a benchmark on the job. Maybe the street, there's a button on the street where they've already surveyed, the government has surveyed that street and they say it's at elevation 151 feet 3 inches. All right. Well, they might take that as their benchmark and measure everything off of that for the job. Um, I don't know if I can. Let's see if we can we zoom in. Here's a parking lot. These are those contour lines. You see how the contour lines show the elevation of the surrounding land? And again, when they do build this building, they're going to come in here and dig all of this out. But this will tell them how much dirt needs to be removed or added in order to give them a flat area where they can pour their slab, and they can continue on from there. You can't just add a lot of earth. Uh, if you brought in truckloads of dirt and poured it out and then built a building on it, that dirt's going to settle. That building will lean, just like the Leaning Tower of Pisa. That's what happened over there. They started their foundation, and then after a couple of months, it started to sink. And after it stopped sinking, they took some measurements of how compact the soil was, and they decided, eh, it's, it's close enough. Let's continue. So they finished building that bell tower. That's what the Tower of Pisa is. And it's leaning to this day. Anyway, uh, so if they bring in a lot of dirt, they'll actually bring in much more dirt than they need. They'll bring in tons of earth and build up big mountains of dirt for the weight, so that it'll compact the dirt below it, and then they'll let it sit for a month or two. After that's done, they'll come in with trucks and they'll take out all of the dirt they don't need, and the dirt that's left behind is nice and compact, so it's not going to settle, and the building will stay put where they put it. All right. So here are different coordinate system. There you go. These are different. Here's landscape. So this is showing where they're going to come in and put trees when they're done, make it look nice and beautiful. 1.5.2, the architectural plan. Architectural plans, let's see what they say here. Drawings that show the design of a project, also called architectural drawings. Show the design of the project. Look at the architectural plans first, because all of the other drawings follow from them. Architectural plans, the most general, they show how all the parts of the project fit together. One part of an architectural plan is the floor plan, also known as the plan view, a drawing that provides an aerial view of the layout of each room. Any drawing made looking down on an object is commonly called a plan view. A floor plan is an aerial view of the layout of each room. It provides the most information about the project. It shows the exterior and interior walls, doors, stairways, and mechanical equipment. It's like you took a building and you took the roof off, and then you look down inside that building. That's what the floor plan is. The roof plan shows you what the roof looks like, drawing a view of the roof from above the building. So here's a roof plan. They're showing that this is the roof, and there's a parapet wall maybe around the outside, and this might be an elevated area where they're going to put air conditioning, or if there's an elevator, they might put the elevator room. They're going to put things up here on that slab. Before the introduction of large format plotters, printers, and copiers, technical drawings were reproduced using a contact print process that utilized light-sensitive paper to produce what were called blueprints. The name blueprint came from the fact that the reproduction resulted in a negative of the original drawing shown with white lines on a blue background. This technology allowed construction drawings to be reproduced quickly and accurately. The term blueprints was typically used to describe any set of technical or construction drawings. Okay. Elevation is another element of architectural drawings. An elevation drawing, it says side view of a building or object showing the height and width, is a side view that shows the height. On a building drawing, there are standard names for different elevations. For example, the side of the building that faces south is called the south elevation. Exterior elevations show the size of the building, the style of the building, and the placement of doors, windows, chimneys, and decorative trim. So if you see an elevation drawing, you're looking in the opposite direction as the name of the drawing. Let's see if I can get a new page here. So I'm just going to do this real quick. Here's a building, and here's the front of the building. And if this is north and this is south, the south elevation will show this entryway right here. It'll look like you're looking north at the south wall of the building. The east elevation, you're actually looking east. So if this is the east elevation, this building has a peak in the middle running north and south. So you see one side of the roof over here. This is this side right here. There's the east elevation and the west elevation and the north elevation. Again, you'd be standing here looking south to see the north elevation. So you're looking at the opposite, in the opposite direction as the name of the elevation drawing, if that makes sense. Another element of an architectural plan is a sectional or section drawing, which shows how the structure is to be built. Section drawings are cross-sectional views that show the inside of an object or building. They show what construction material is used to use and how the parts of the object or building fit together. So here is a section view, and it's like they took a slice of the building, and you can see the ceiling and this insulation, and you see the wall with insulation in it, you see the roof, here's the eaves, and what does that eave say? I don't know. I can't see it, it's too small. It almost, well, and then there's a gutter, a rain gutter on the outside. All right. So this is showing, and then look, here's the ground. There's a cross hatching. So this is the earth. This is the bottom floor. And they actually have a basement underneath the ground. They're showing that here. Here's a poured concrete wall and slab on a footer. And there's the section underneath. Even more details shown in a detail drawing, which are enlarged views from some special feature of a building, such as floors and walls. They're enlarged to make the details clearer. Often the detail drawings are placed on the same sheet where the feature appears in the plan. Sometimes they're placed on separate sheets and referred to by a number on the plan view. So here's a detail drawing. It shows a close-up, and it's showing that the rebar in the footer has to be overlapped a minimum of 2 feet, 2-foot minimum lap around this corner. So this is the concrete foundation wall corner detail, residential poured wall, not to scale. Change orders required where there are changes to the scope of work on a project which already has a contract in place and that has been agreed upon by all parties involved. These changes could come about from design changes, unforeseen site conditions, or work that is added to or deleted from the scope of the project by the client. The change order document describes the changes in detail that could include the construction scope, design, project schedule, and even cost. Here's a window schedule that tells you each window on that job by a letter type, 4'2" by 4'2". It's clear anodized aluminum. Here's a change. Look, they made a change on the print. They put it inside of a cloud. And there's the change number, change order. There's a 1 inside of a triangle. And you can go to the notes and find out what that change was. Frame sizes have been indicated assuming 1/2" joint adjacent to metal panel system. Alignment of joints with metal panel module is required. Intermediate mullions to be centered on adjacent metal panel joints. So they added that. Somebody thought of it after the fact and they said, oh, we've got to put that in so that they do it correctly. All right, let's make a change order. It's a revision. Structural plans. Structural plans, a set of engineered drawings used to support the architectural design. Are a set of engineered drawings used to support the architectural designs. The first part of the structural plan is the general notes. These notes give details of the materials to be used and the requirements to be followed. General notes for structural plans. These are all notes. That's what I say. Sometimes you have too many notes to put on the blueprints themselves, so you put them in the specifications, the specs. The structural plans also include a foundation plan, a drawing that shows the layout and elevation of the building foundation, which shows the lowest level of the building, including concrete footings, slabs, and foundation walls. They also may show steel girders, columns, or beams, as well as detailed drawings to show where and how the foundation must be reinforced. So here's a foundation plan, and they're showing that these mullions or stanchions, these are poured concrete, and then they have columns or beams coming out of them to support the building or to support the parking garage or what have you. The structural plans show the material to be used for the walls, whether concrete or masonry, and whether the framing is wood or steel. That's a highlight. So here's structural section drawing, foundation details. They're showing here's the concrete slab, here's a footer, here's rebar put in the footer to hold the columns. They actually have these threaded rods. See typical detail for anchor bolt detail. This anchor bolt has a bend in it so that it's stronger. It's going to hold the concrete. It's not just a straight piece that can be pulled out. They put that foot on there and it grabs the concrete. Approved undisturbed subgrade. See general notes. Mechanical plans. Mechanical plans are engineered plans for motors, pumps, piping systems, and piping equipment. That's a highlight. These plans incorporate general notes containing specifications ranging from what the contractor is to provide to how the contractor determines the local location of grills and registers. A mechanical legend defines the symbols used on the mechanical plans. A list of abbreviations spells out the abbreviations found on the plans. So the mechanical plans, engineered drawings that show the mechanical systems such as motors, piping, fluid lines, what have you. And here's mechanical plan general notes. Here's the legend. Tells you all the different items that might be on that mechanical drawing. Mechanical plan list of abbreviations. Domestic cold water. Domestic hot water. P&ID drawings. Piping and instrumentation drawings. This is if you're doing a commercial or an industrial job. You have these schematic diagram of complete piping system. Here again, the bow ties are valves. You have level sensors and transmitters. If it's a transmitter, it actually sends it back to a computer. If it's an indicator, it's just a gauge in the field. So you have temperature and pressure. This is a temperature indicator and a pressure indicator. Like I say, they have different valves here, and they have, to me, that looks like a temperature sensor is going to open or close this valve. If something gets too hot, or if they're waiting for it to be a certain temperature to send it on to another part of the process. Cooling water drawing number, condensate drawing number. So these continue on, and they're telling you which drawing to go to see the rest of this. For more complex jobs, a separate heating, ventilating, and air conditioning plan is added to the set of plans. Piping systems plans for gas, oil, or steam heat may be included in the HVAC plans. Mechanical plans include the layout of the HVAC system, showing specific requirements and elements for that system, including a floor, a reflected ceiling, or a roof. HVAC drawings often include an electrical schematic that shows the electrical circuitry for the HVAC system. HVAC plans can be both mechanical and electrical drawings in one plan. A lot of times on a job like this, we will supply a disconnect for the HVAC equipment. And then the HVAC installers will hook up their equipment to that disconnect. We'll run the electrical up to the point of the disconnect, and then they'll pipe it in from there. They'll wire it in. HVAC drawing 2 of 2, mechanical detail drawing for hot water riser. Plumbing piping. Same thing with plumbing plans. Engineered drawings that show the layout for the plumbing system. They have both hot and cold water. They're engineered plans showing the layout for the plumbing system that supplies the hot and cold water, for the sewage disposal system, and for the location of plumbing fixtures. So these are all the plumbing fixtures they have here. There's a men's room and the woman's room. Trying to see if these are sinks. I'm not sure. No, this looks like a stall. This is a handicap stall. This is a handicap stall. This is another stall. These are urinals, and then these are sinks. The women have all stalls and sinks. Plumbing isometric drawing, a type of three-dimensional drawing that depicts a plumbing system. The isometric drawing is a three-dimensional drawing that depicts a plumbing system and serves as part of the plumbing plan. So it shows them how to run their piping. And they go in 3 dimensions here. So this might be the x-axis, and this might be the y-axis and the z-axis. But this tells them exactly where to run their piping in order to be most efficient and to get everything piped in. You have wet walls, and you don't want to have too many wet walls. You want to make sure that everything gets fed. An isometric drawing is a type of three-dimensional drawing, also known as a pictorial illustration. Isometric construction drawings typically depict objects at a 30-degree angle to provide a three-dimensional perspective rather than a flat two-dimensional view. See, it's easier for them to realize how this is run. There you go. There's their north, south, east, west, up and down. Electrical plans. Engineered drawings that show all the electrical supplies and distributions. They're engineered drawings for electrical supply and distribution. These plans may appear on the floor plan itself for simple construction projects. Electrical plans include locations of the electrical meter, distribution panel, switchgear, convenience outlets, and specialty outlets. Here's general notes for the electrical sheets. The electrical plans can include lighting plans, which show the location of lights and receptacle, power plans, and panel schedules. Electrical plans have an electrical legend, which defines the symbols used on the plan and a key to the abbreviations used on the plan. So all of these arrows are home runs. When you see an arrow like that, it means this circuit goes back to the panel, wherever the panel is. I can't see it in here, but here's the elevator. I'm not sure where the electrical room is, but all of these home runs are going home. From the arrows, I would assume that the electrical panel is somewhere over here, but I can't see it on this drawing. My eyes aren't good enough. Anyway, those arrows are all home runs. Here's the panel schedule. It tells you the name of the panel, the voltage of the panel, 277, 480, three-phase, 4-wire plus a ground. And it tells you each circuit breaker and what it feeds. And look, there's a change order. There was a revision, so they put it in a cloud. Here's a revision. They put it in a cloud. And there's one in a triangle. So all three of these revisions these were made all at the same time. It's the same revision number 1. Electrical symbols list, electrical abbreviations, visualize before building. It's important for a builder to be able to visualize a finished project before starting it. Detailed drawings help builders visualize different parts of the structure long before they measure a board or hammer a nail. By visualizing, builders can plan ahead and anticipate potential problems. This saves time and money on the job. Nowadays with computers, they'll make a 3D rendering of that building, and you can walk around inside the building virtually, and you can see if 2 doors are going to swing and hit each other. It's like, oh, we need to change one of these doors to swing in the opposite direction so they don't hit each other. Specifications clarify information that cannot be shown on the drawing. Specifications are very important to the architect and owner to ensure compliance to the standards set. So air handling unit, it's going to tell you exactly, there you go, shall be double wall McQuay or approved equal. Other drawings, documents. An important drawing that may be included in a set of drawings for public buildings, multifamily residential buildings, and similar structures is a fire protection plan, drawing that shows the details of the building's sprinkler system. This drawing shows the piping, valves, heads, and switches that make up a building's fire sprinkler system. A fire sprinkler symbol list is used to include and included on a separate sheet along with the fire sprinkler specifications, the details, and the assembly drawings and riser diagrams. One 1.0.0 section review. It says revisions to the drawing are entered in the revision block and must include the date and the initials of the person who made the revision at a minimum. Code books and specifications for a construction project often include the meanings of symbols. When a plan is marked NTS, the dimensions are as measured on the drawing cannot be used to build the project. True, because it's not to scale. You have to field verify. What is the length in feet and inches of the section of duct using the architect's scale? Where is it? Figure SR01. So we're going 1/8 of an inch equals a foot. So that's 1, 2, 3, 4, 5, 6 feet. I'm going to say that's what, 6 feet 10 inches? That might be 9 inches. I'm not sure. It's hard to say. So each one of these is 2 inches. 2, 4, 6, 8, 10. I guess I'd say 6 feet 10. I don't know. Oh, they're giving us a choice here. 6 feet 5? No, I don't agree with that, but they're saying 6 feet 5. I think they're wrong. It's what's the length in feet and inches? 1, 2, 3, 4, 5, 6 feet. Yeah, that's not 6 feet 5. Yeah, that's like 6 feet 10 because this is an entire foot. In fact, their dashes are a lot larger than this being 1 foot. That whole thing is off. Anyway, let's move on. A site plan shows the location of the building from an aerial view. Yes. All right. Very good. Well, This concludes 00105, Introduction to Construction Drawings. I hope you got a lot out of this video. Please like and subscribe if you did, and I'll see you on the next video. Thank you. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.